Okay, so this is entitled The Ugly Truth, and you'll see why. So somebody told me I should make it the Dr. Hall Halloween Spooktacular since I do it the week before Halloween, and yes, you are going to be scared. So, to open, just a couple real quick questions, just to get your mind in the right space. So, first question, can't you eat just anything? No, of course not. So why do we treat our cars and our pets better than we treat ourselves? Would you put cheap gas in a Ferrari? No. Do you use cheap parts to fix a Ferrari? No. So would you put cheap fuel in what you hope is a Ferrari? Your body? No. And pets, why do we treat our pets better than we treat ourselves? We're so concerned with what goes in our pet food. Is it natural? Does it have, does it have processed ingredients? And when you see a child giving a Snickers bar to a dog, what do you say? No, that's bad for the dog. But you'll grab that Snickers bar and you'll eat it for yourself, won't you? So if we wouldn't let a dog eat a Snickers bar, why would we necessarily eat one for ourselves? And I'm not saying you can never eat Snickers bars again. I'm just saying, get the mindset where some of these things we eat on a daily basis may not be so good for us. So, tonight's agenda, health trends over the last century. This is where I plan to scare the socks off. What are we putting in our bodies? Cardiovascular disease, the #1 cause of death in the US. And then toxins and bioaccumulation, medications that aren't so good for us, that we might think are. Okay, so health trends over the last century. These research articles have been assembled by the CDC and multiple national agencies. So these are the National Institute of Health, the CDC, and other people that actually look at this stuff. So this is where this research comes from. So we're looking at cancer. So colon cancer, more predominant in men. Now, most of these researches start in the early 1900s. You're going to notice the graph has to start somewhere. Now, we don't have correlative data for before this point because no one was keeping track. Because some of these cancers didn't actually appear until the 1950s. So colon cancer, on the rise. Breast cancer, of course, on the rise. Bladder cancer. This one's really neat because out of all the other correlative data that we have, this one doesn't even start till the 1950s. But we started keeping track of cancers in the early 1920s. So this one is a very unique example of a cancer that was never before recorded until the 1950s. So something in that early industrial revolution we had in America started to change already. So a brand new cancer popped up in the 1950s. We're going to look at a couple other examples of this. Now, lung cancer. This is one of the most unique graphs. And here's where we're going to have some audience participation. Now, this one started earlier because, again, Industrial Revolution, this is something we actually had a good look at. So, as the century progresses from the early 1910s into the 1940s, lung cancer has a relatively shallow incline. It's going up, but very shallow. But then, in the 1950s, boom, a huge, tremendous shoot on cancer, lung cancer. Why is this? Cigarettes, of course. But what was really cool? TV, movies. What was really cool back in the 50s? Clark Gable, right? Everybody on the silver screen just smoking it up, and everybody wanted to have a cigarette. So guess what? Lung cancer starts to skyrocket because we know cigarettes cause lung cancer, right? Okay. So get that in your mind because it's going to come back up again. Now also, this is one of the only ones that shows a sharp decline in the early 2000s. Why is that? That's when not just the labels came earlier, but the commercials. The anti-smoking commercials came out in the early 2000s. So, we now know that we can make a direct effect on a very predominant cancer by public awareness and by, okay, you smoke cigarettes, you get lung cancer. So that's going to decrease some people from smoking cigarettes, hopefully. Now also, diabetes type 2 on the rise big time. Alzheimer's disease. This is a predictive graph. We're here in 2018, but look at these numbers from where we used to be. And this is a predictive graph. Why would a disease that should not have necessarily a lot of genetic factors, or of course if our population is increasing we'll see some increase with genetics, but why would we see such a huge prediction on this graph? So we're going to come back to that. Dementia on the rise, especially early onset dementia. So something we haven't really seen before. People are getting dementia at earlier and earlier and earlier ages. Why would that change? Numbers we can see, but why would the age start to change? How about mortality rates of dementia? Back in the 1980s, if you got dementia, you not necessarily were going to die from dementia, but now look at the mortality rates from dementia. So now we're starting to see not only are these diseases occurring in younger populations, but they're way worse, and it's killing them, exactly, where it didn't used to. So something's changing. How about deaths from Parkinson's? Again, back in the early 1980s, almost zero. Now we're starting to see these neurological diseases advance at such a rate that the patients actually will die from that condition before natural causes. And these numbers, I mean, these are huge graphs. How about autism? Now this one's very popular in the news, especially with talking about vaccines. Not saying vaccines have anything to do with autism, but just look at the numbers. Back in 1975, it was 1 in 5,000 children were diagnosed with autism. Now, in just 2010, it's 1 in 110. And they say it's going to be more than that very soon. And here's the thing. So we have changed the diagnostic criteria for autism. So we now have broadened that diagnosis. So more children are encompassed in it, which does help to show, well, it helps to explain some of the increase, but not such an increase as this. Now, let's talk about obesity. Back in 1985, the CDC decided we're going to start tracking the obesity of America because we started getting bigger back in the 1980s. A lot of stuff happened in the 80s, not just Ghostbusters. So, now, back in the 1980s, they had 2 colors on the map, only 2. They didn't even get to use this one. Now, this is the 1980s. And they had this red color, woo, for warning. But no one state was anywhere near it. And of course, there wasn't a lot of data yet. So 1990, they get to use another color. So, but still, nobody's in the red. Whew! Still dodging a bullet. And you know what? The CDC never thought they would get to that. They thought that would be some type of an absolute, oh, that'll never happen. So, 1997. So this is just 7 years. We start to see the red color being used. But look how light blue this map is, how pretty those colors are. And now look at all the dark blues. Now keep an eye on Colorado. We're number 1. So look, in 2000, this is just 3 years later. Only 3 years later, look how much red. We went from 3 red states to, I'm not even going to count how many that is, including Alaska. How dare they? But look at Colorado, the single holdout. Still down here, 10 to 14%. We were at 10, but now we're kind of climbing our way up. This is 2001, Colorado, the only light blue state, still 10 to 14%. Look how much red. But now, from 2000 to 2001, 1 year, they had to add a new color because we used up all the red. So now 25% or more of that state was obese. So, and I think that's the great state of, is that Alabama? How dare they? So, this is 2001. Don't worry, more to come. So, 2007, they had to add another color. And Alabama leads the way at greater than 30%. But Colorado, still the only blue state. Not talking politics here. So, 15 to 19%. We did increase out of the 10 to 14 into the 15 to 19%. But still the lone holdout of the entire country. Oh, darn. 2010, we lost it. So now Colorado joins the rest of the states, 20 to 24%. We still have our new color at 30% or greater. And guess what? 2013, we had to add another color. And guess who leads the way? Alabama, again, in my home state, West Virginia, 35 to 40% of the state is considered obese. This is terrible. From the 1980s. Question.
It's actually Louisiana, not Alabama.
Is that Louisiana? Okay. Okay. Mississippi. Okay. I'm terrible with social studies. Okay. So, disorders of all types are on the rise. Why? Why would this be happening at such an alarming rate since the 1980s? We're talking 30 years. So, let's zero in on the #1 killer in America. I think by examining the #1, I think we'll be able to tell ourselves a little bit more about this mystery. So, cardiovascular disease, #1 killer in America. So, this is an artery. These are red blood cells. What's that yellow stuff?
Plaque.
Plaque. What's plaque made of? Cholesterol. Fat, goo. So, okay, so fat, right? But cholesterol gets a really big tagline in this plaquing. So, everybody knows what this is, and this is what causes cardiovascular disease. Plaque builds up in the arteries lose their elasticity, they also lose the lumen or the space inside, so we get high blood pressure, peripheral issues, our artery system starts to collapse, our heart has to work too hard, our heart enlarges, and then we die. That's cardiovascular disease in a nutshell. So, a lot of other factors in it, but that's the short and sweet. So, cardiovascular disease mortality rates in the United States. So, this is the #1 killer in the United States. And America is the #1 country in the world. Now, if we know this is our #1 killer, and we devote all of our resources to it, should we be able to make a dent in those numbers? Yes, we should. But why is it at an all-time high? Every year, the amount of deaths from cardiovascular disease rises. But yet, we have more blood pressure medication than ever. We have more statin drugs, so we have more cholesterol-lowering drugs than ever. We have antiarrhythmic drugs. We have all kinds of treatments for cardiovascular disease. But why aren't the numbers dropping? Why does every single case, why in every ratio is it going up? So here again, so this is cardiovascular prevention drugs prescribed. We're prescribing more drugs by a factor of 10 than we ever have, but the numbers keep going up. That doesn't make any sense. So if we're treating the disease, but we're not fixing it, what are we doing? So here is a 10-year study on, this is just statin drugs. So these are other brands, Lipitor, Crestor, the top 2 brands. So we've got a couple things here. So we're prescribing a ton of statin drugs. So cholesterol drugs are literally coming out of our noses, but we're not fixing the problem. So if cholesterol is the #1 cause of plaquing, and plaquing is the cause of cardiovascular disease, why aren't these numbers going down? So heart disease again, this is 97 to 2011. So everything is up. So what's the enemy here? Statin drugs are the most prescribed drugs of all time. Since the 1980s, we have gone up 500% in their prescriptions. So if these are the most prescribed drugs of all time and they're supposed to help cardiovascular disease, why are the numbers not dropping? So in fact, mortality is increasing and the average age of death hasn't changed. You would think that if the average age of death for cardiovascular disease was 55 years old in 1984, it's still 55 now. What is the problem? So, cholesterol. We're going to zero in on this baddie for just a moment. So, cholesterol is a naturally occurring molecule in your body. It's necessary for proper body functions. Now, cholesterol is the base molecule for all of your hormones. Hormones are important. That's how your body gets things done. So it's also responsible for transporting fat and for metabolism and storage. But also your brain is made up of 80% cholesterol. So myelin is a substance that surrounds your nerves. And nerves are really important. Nerves are 80% myelin. Myelin is 80% cholesterol. So that's an important number. So cholesterol, bad or good? Cholesterol isn't bad for you. Cholesterol is necessary. Cholesterol is very good. Now, high numbers of cholesterol may be bad for you. But if we're lowering cholesterol and we're not fixing the problem, is cholesterol really the enemy? So, when heart disease was first researched, what they did was they took a bunch of people that had died from heart attacks, they cut open their arteries, they found this yellow goo. They took the yellow goo, they put it in a mass spectrometer, guess what it was? Cholesterol. So automatically, cholesterol becomes the bad guy. Now this is the 1980s, when we first heard that eggs were bad for us because of cholesterol. So, and now, we flip-flopped several times on eggs over the last couple decades. We're going to talk a little bit more about that here in a minute. So, this is where cholesterol got the bad reputation. Undeserved, however. Now, finally, after years of research, we determined that cholesterol sticks to the walls of the arteries, but it's not the cholesterol that's the problem. Our arteries themselves have a problem and decrease all kinds of flow issues. So, the arteries themselves have an issue. So, the lining of the artery becomes damaged, and it creates rough spots. And those rough spots then attract and collect cholesterol. And so then plaques start to form, and then other cholesterol molecules attach those, and it gets bigger and bigger and bigger. But it was the arterial issue, the damage to the artery, that caused the problem, not the free-floating cholesterol. So, cholesterol-lowering medications increased 500-fold over the last few decades. No change in mortality rate or age for heart disease. In fact, it's at an all-time high, despite all of our wonderful medications. So why do we still prescribe them? That's the question. So what if I told you that statin drugs were really bad for you? Would you believe me? Good. So this study was done in 2011 by the National Institute of Health. These are the people who are responsible for your health in America. They make policy, and then they send that policy to the FDA, who ignores it. So, this study they did shows that organisms on a statin drug, so here's their direct findings. All you need is this one sentence. Our findings therefore suggest that inhibition of cholesterol synthesis is detrimental to neuronal tissue. Does anybody know what neuronal means? Brain and nerves. So this study says that statin drugs rot your brain. So let's talk again about dementia. Now wait a minute. Wait a minute. Back in the 1980s, we just talked about, that's when statin drugs came out, right? So, if all of our neurological conditions are going up starting in the 1980s, and statin drugs came out in the 1980s, I think we found ourselves the red herring. So we've got that. So hand in the cookie jar. So now, just so you know, in 2011, this number, so 106,000 Americans, this is from the CDC. In 2011, 106,000 Americans died every year from normal side effects from properly prescribed prescription drugs. This is the number the CDC expects to die from physicians prescribing regular drugs. This number is now 160,000 Americans every year. That's the number we expect from properly prescribed prescription drugs and their normal side effects. So we expect this. That's BS. So, how effective are our drugs? Well, let's dig into that just a little bit, will we? So, in June of 2010, a report in the Journal for General Internal Medicine studied a look at 1976 to 2006, and that was the most recent year available in this 2010 study. So what they found was that, in fact, of 62 million death certificates in the United States, almost 250,000 deaths were coded as having occurred in a hospital setting due to medication errors. Now, these aren't the properly prescribed ones. These are the errors. So that's a lot. Now, an estimated 450,000 preventable medication-related adverse events occur in the U.S. every year. This is from the CDC. The cost of these adverse drug reactions to our society, more than $136 billion annually, greater than the total cost of cardiovascular or diabetic care. Now, we're just talking drugs now. We're off of cardiovascular disease for a moment. So adverse drug reactions cause injuries or death in 1 in 5 hospital patients. Now, our healthcare system is good, but here's where we actually rank. The United States is 38th in overall healthcare rankings in the world, but yet we spend the most. We are number 1 in expenditure. So we spend a lot of money, but it's not really getting us anywhere. Now, here's where we rank again. So these are pretty much the top countries in the world for healthcare. The UK, believe it or not, is actually number 1. So Switzerland's number 2, Sweden, Australia, Germany, the Netherlands, New Zealand, Norway, France, Canada's just above us, still not doing super great, but we're pretty low, even below Canada. So our healthcare system is really good at emergency care, but we're getting the actual healthcare part of healthcare wrong. So, what is really causing cardiovascular disease? So, again, we're just zeroing in on this one thing, and then we'll kind of bring this full circle. So, inflammation is a big word. Inflammation is a complex biological response of vascular tissues to harmful stimuli, pathogens, or irritants. It is initially a protective response. Inflammation is there to fight baddies, bad things. So, why are our bodies becoming inflamed? So, inflammation is our key word now. So, let's meet some of the criminals. So, this is low fat is not how to lose weight. So, in the early 1970s, 1980s, low fat guidelines came out. America's getting fatter. You saw the graphs for yourself. So, we decided we'll just take fat out of food. Problem solved, right? No. So, when you take fat out of food, you have to replace it with something artificial so it still tastes good and it stays together. So when the low-fat guidelines came out, obesity actually skyrocketed. So then we started getting fatter at an alarming rate. And then the CDC came out with new colors for the maps. So now, this is 2005, 2006. That's a marked increase from the 1980s. A lot of this stuff started in the 1980s because we thought we were so smart that we could fix the problem with science. But we ended up messing it up. So, but also we needed to feed more people. We have to grow food faster, quicker, bigger, right? Apples need to be brighter. Carrots need to be oranger. So we started using a lot of pharmaceuticals. We use chemicals now. So this is a grade 3 chemical mask, and he is spraying your vegetables. If it's not safe to breathe, do you think it's safe to ingest? Now so yeah, they wash the plants, but this stuff is taken up through the roots. It's in the plant. You can't just wash it off.
And they put it in the seed now.
Yeah.
The DMT is in the seed.
Yeah. We put it in the plant before it's there. So this is pesticide use since 1995. Look how little pesticides we used in 1995. What the heck are we using this much pesticide for? So, and these are all of the crops that we need. How about herbicides, insecticides, fungicides, and others? So, herbicides and insecticides, so we're using these, and these are alarming numbers. So, yes, we're feeding more people, yes, we're growing more crops, but these things are in the food. Pesticides are a neurotoxin for bugs. That's how they kill them. It attacks our nervous system. It does the same thing to us, just it's supposed to be in very low quantities. So let's talk about low quantities. You see how this just flows so nicely? So, now, if we have just a little bit of pesticide, is it going to kill us? No. What if we have a little bit every day for our entire life? Is it going to affect us? Yeah. So, bioaccumulation and biomagnification. This is how stuff works in nature. But you have to understand, human beings are a whole special kind of natural. So, this is just how bioaccumulation occurs over time. Baby fish is born. No mercury in it. He swims around the ocean, he eats plankton, he eats other things, and little bits of mercury, tiny little bits, start to accumulate in that little fish's body. As the fish gets older, the mercury levels rise because our bodies can't get rid of mercury. Neither can fish. Nobody can. So mercury stays there, and it just starts to accumulate. Now, we eat the fish, right? So biomagnification is different than bioaccumulation. It's similar. So, little shrimp that have a little bit of bad stuff in them. Fish eat the shrimp. The fish have a little bit of bad stuff in them. Seal eats the fish. Seal eats a lot of fish. So he gets more bad stuff in him. Bear eats a seal. Bear eats a lot of seals. He gets a lot of bad stuff in him. Human beings are the only creatures that have both of these happening simultaneously. Because we eat the animals. We eat everything. Right? We eat everything. So both of these are happening in us. So the problem starts with these molecules we can't get rid of. Mercury for one. So as we accumulate mercury throughout our lives, mercury is a neurotoxin. And your body can't get rid of it. So if we eat a lot of junk that has mercury in it, guess what? It starts to accumulate. So these two processes are what is at play when we talk about pesticides, herbicides, fungicides. Because your body can't get rid of this stuff. So it just builds up. So, we're going to talk about another couple bad guys. MSG, one of the worst molecules ever created. MSG is touted as a flavor enhancer. Yeah, so everybody heard about MSG in Chinese restaurants. They sprinkle it on there like salt because it makes the food last longer, right? So they don't want, that way they can serve yesterday's tray today. So MSG causes a hyperinflammatory response inside your body. So this inflammatory response, when you have this inflammation, your body is trying to react to something that's bad. But if it's occurring every single day, the inflammation gets out of control and it starts to actually attack your own cells and your arteries and all that other really bad stuff. So this inflammatory environment is really bad for us. And one other thing about MSG, it's really good at making people fat. So when a researcher wants to make a mouse obese for research, they just feed him a little cup of MSG. It's called MSG-induced obesity in mice. And researchers use that every day to make fat mice so that they can then study fat mice.
Great.
Yeah! So MSG causes obesity and inflammation. Inflammation causes cardiovascular disease. Exactly. Soda. Literally acid. You can clean a chrome trailer hitch with Coca-Cola.
Oh, yeah.
Works really good. So soda has all kinds of really bad stuff in it. Not just the artificial sweeteners which make your body chemistry go absolutely haywire, but high fructose corn syrup. It's like rocket fuel for your body. So you don't put rocket fuel in a Honda. It'll burn out the engine. High fructose corn syrup does the exact same thing. Because when you have such a concentrated form of energy, this high fructose corn syrup creates a hyperglycemic response, which then eventually leads to a hyperinflammatory response, which inflammation again causes cardiovascular disease. So high fructose corn syrup is one of these really terrible things that we've done to save money, save time, make things taste sweeter, and just make money. So these are what we're up against. So now, soda, diabetes. So remember, diabetes is also on the rise. So now, we're going to talk about milk. Who likes milk? Good. We got some hands this time. So, you are not a calf, therefore, milk is not for you, period. Not even cows drink milk after they're babies. So, once a cow gets to a certain size, he never drinks milk again. Right? No, so, the claim to fame for milk is what? that makes a body, does a body good, right? Makes your bones strong. What if I told you that it did the exact opposite of that? Would you believe me? Better. So, now, again, back to the 1980s. I know I'm really harping on the 80s. So, 1980s, the tagline, milk does a body good, comes out, commercials all across America. As a matter of fact, every decade, the Milk Board of the United States pools their money together to create an ad campaign every decade. The 90s was, got milk. So every year they come out with these taglines, these little jingles to remind you, hey, milk, drink us. So, and this is a part of a marketing campaign. But their claim to fame is milk is good for your bones. So not only is osteoporosis and the occurrence of hip fractures not dropped since the 1980s, but it's on the rise. And so it has been since the 1980s for the first push for milk when it does a body good. So these are hip and knee replacement trends since 2000. Now, what you're going to notice is all of them are on the rise. So if our bones are supposed to be made stronger by milk and we're drinking milk, why are our bones getting weaker and weaker as the decades go on? Now, we could explain some of these graphs by, you know what, we've gotten really darn good at these surgeries. So, and we're just, everybody needs one. But, so that can explain some of it. Because we have gotten a lot better at these surgeries. So we can do amazing things by replacing these joints. But why are the bones themselves deteriorating at such an alarming rate? So we're going to zoom in on milk. So the main protein in dairy is called casein. Casein causes a highly inflammatory reaction in your body, and it creates that inflammation again. It creates a highly acidic environment. An acidic environment in your body must be buffered. The best buffer in the world, calcium. We used to have a biochemist who loved to shout that one out. Calcium is the best buffer in the world. Where is calcium found in your body? Your bones. Milk makes your body's environment acidic. Then your body has to buffer that by pulling calcium out of the bones. So milk does the exact opposite of its actual claim to fame. And this is real research, not making anything up, 100%. So in order to buffer that acidic environment, we're actually eating away our own bones. But that's not all casein does. So in 2012, they did a research article on prostate cancer. So again, prostate cancer, only found in men, is on the rise. How many men here like milk? Okay. So what if I told you that this research article in 2012 stated that the correlation between milk and prostate cancer is as strong as cigarettes to lung cancer? And guess what? Casein protein actually turns on the TORC1 signaling and initiating progression of prostate cancer. Casein protein directly activates the genes that turn on prostate cancer. Real research. But guess what? This is done in 2012, which means it's going to stay in the research circles for about a decade. So around 2022, you lovely folks will hear about it on Fox News.
Doctor, do you know how many people were in that study? It says comprehensive, but do you know?
I don't know the exact numbers, but you can look that up, and I'm sure it has it in the abstract. Yeah. So, but again, now study. These are just one study, So now the China study, they did specific research on casein protein. The China study was the largest study ever to be conducted in the world on cancer. So cancer rates in China, which I know is not America. But what they did was they correlated certain cancers into clusters in a certain region in China. And then they started to narrow down why those regions had certain types of cancer. What they really found was diet has a lot to do with this stuff. Casein protein in particular was zeroed in. So the China study concluded that when we give mice casein, and we also give them a little aflatoxin that causes liver cancer, when you do that together, mice develop liver cancer. But if you take the casein away, the liver cancer went away. Same mice, they gave the casein back. The cancer came back. They took the casein away. The cancer went away again. They did this over and over and over on the same mice. And the cancer would come back and then regress. All based on the amount of casein they gave the mice. Casein protein, which makes up the majority of milk, is one of the #1 killers out there. And casein protein has now been linked to over a dozen types of cancer.
You keep saying milk.
Yeah.
Is this specific to milk or is
Yes.
this all dairy products?
Well, casein is contained in all dairy products, but milk has the highest concentration of it. So milk is very bad. All dairy is bad, but milk is the #1. #1. And guess what? Low-fat milk has even more casein because they take the fat out of it. So guess what's left? The proteins. So casein, low-fat milk has the highest level of casein of any milk. So, still got milk? That's my little tagline. So, what about other cancers? So, free radicals. Free radicals damage DNA. Free radicals are created by inflammation. Inflammation is one of the #1 reasons we have all these wonderful diseases. But free radicals damage the DNA inside your cells. Then, once the DNA is damaged, the cell recreation process, or when it actually splits and multiplies itself, it has that damaged DNA. And a group of dysfunctional cells with damaged DNA is called, guess what? A neoplasm, which is cancer. Exactly. So a group of damaged or dysfunctional cells is called cancer. So, one common link to everything we've talked about this evening is diet. So processed foods, highly inflammatory things. All of this stuff is leading us down this road where every disease, every major disease known to mankind is at exponential levels. But yet, our healthcare is supposed to be the best it's ever been. So why do we still not see this problem? So the human diet is becoming more and more artificial, processed, and inflammatory. So what do we need to do? So now I've scared the pants off of you. How do we fix this? So, what do we do now? Don't worry, all of this is in your handout. So cut out dairy immediately. Switch to almond milk or cashew milk. There's no dairy in that, and guess what? It's actually good for you. Now, I would say soy milk, but now soy is getting a bad rap too for the estrogen thing. So, you know what? Almond milk, cashew milk, they haven't found anything wrong with that yet, so let's stick with that. I'm not saying they won't buy tomorrow. So limit your exposure to refined and processed foods. If it comes in a box, it is not good for you.
If it's got a commercial.
Period, the end. If it's got a commercial, it's not good for you. If the ingredients list has more than 2 things, it's probably not good for you. If the first ingredient in something is water, it's probably not good for you. So, to fight free radicals and inflammation, we need things like ginger root, raw cacao beans, tea, coffee beans, vanilla beans, citrus fruits, blueberries, papaya fruit. I still have never seen one of these, but it has one of the highest antioxidant contents of any fruit in the world. Now, toxins, heavy metals, chemicals, these are fought through chelating agents. Certain things like beets, flax seeds, chia seeds, parsley, cilantro. Parsley and cilantro can directly bind to free-floating mercury and pull it out of the system. So, cool. So we're going to zero in on a couple really cool things. So, lots of research has been done in this last decade on things that can actually do something about inflammation and free radicals. Turmeric is one of the most amazing things we've found. Now, there's a lot of research out there on turmeric. A lot of the studies are inconclusive, but here's some of the really good ones. So, turmeric has been shown to be a tremendous anti-inflammatory and also antioxidant. So, turmeric can have an effect on cholesterol. So, one study reported a drop on average, total cholesterol was reduced by 32%, bad LDL by 42%, and triglycerides by 39%. Just by taking turmeric. It's a root. It grows in the ground. It's free if you grow it yourself. So, studies have also shown a direct impact on kidney disease, heart disease, and diabetes just by taking turmeric. Minimum effective dose, 3,000 milligrams a day. Now, somebody out there is going to say, but what about the active ingredient, curcumin? Well, a most recent study says that curcumin by itself has good side effects, but the overall root has been shown to have way more health benefits than just the active ingredient. So the most recent studies say, take the whole root. 3,000 milligrams a day. 1,000 milligram morning, noon, and evening. Guess what? You're on your way. And cut out processed foods. How about ginger? Everybody likes ginger, right? And it's all natural. It grows in the ground. If you grow it yourself, it's free. So, ginger has been shown to have profound anti-inflammatory and antioxidant effects as well. So, it also dramatically improved HbA1c, a marker for long-term blood sugar levels and diabetes, leading to a 10% reduction over a period of 12 weeks in a most recent study. 12 weeks of taking ginger, and it brought these people's blood sugar, HbA1c now, mind you, down 10%. So, ginger's been used to treat nausea associated with morning sickness, chemotherapy, and was described by one research article as miraculous in chemotherapy patients for nausea. But it's also an antioxidant, fights cancer and inflammation. In a 45-day study of 85 individuals with high cholesterol, 3 grams of ginger powder caused significant reduction in most cholesterol markers. 3 grams is 3,000 milligrams. Guess what? You're going to see a trend here. So, also, the anti-cancer properties for ginger are attributed to 6-gingerol, a substance that is found in large amounts of raw ginger. So, this has anti-cancer properties. They're actually starting to study this to help us fight cancer. They're giving this to cancer patients, medical doctors even. Guess what the minimum effective dose is? 3,000 milligrams a day. 1,000 in the morning, 1,000 at noon, 1,000 in the evening. Flax seeds. Who likes flax seeds? Yeah. So, a landmark study in 2013 showed that milligram for milligram, ground flax seeds work better than the leading hypertensive medications on the market with 0 side effects. This is just a quarter cup of ground flax seeds a day. Works better than the leading hypertensive medications on the market today. Combined with oatmeal, flax seeds and oatmeal can together lower cholesterol and blood pressure. So it's also a great team for breakfast. Yeah. So guess what? We can start fighting a lot of this stuff just by changing our diet. These are 3 things you can do today. Get turmeric, ginger, and flax seeds. Start having oatmeal and flax seeds in the morning. It'll help fight cardiovascular disease and cancer. So, the ginger and turmeric are probably the 2 biggest things I can advise everybody in this room to start doing now. By decreasing your inflammation, not using medications, not only are you going to start to have better quality of life, but your body can actually start to fight off some of these damaging effects in our arteries and our organs. So those are 3 things you can do now. Guess what else we can do? Exercise. So get healthy, get happy. So, studies have shown that daily exercise not only increases your energy, but also your mood through the release of endorphins. So, exercising makes you happy. 15 minutes of cardio a day is enough to sufficiently increase your metabolism by as much as 25% over time. Now, this is cardio, 15 minutes a day. So, this is like running and doing like active things, not just walking, but 15 minutes of cardio. So, over time, it can increase your metabolism, which once you increase your metabolism, your body just burns fat naturally and you stay nice and healthy and thin. So, studies have also shown individuals' metabolism can remain elevated by 200% for over an hour after strenuous exercise. You know what that means? You do your 15 minutes of cardio and then for the next hour, you're still burning calories. You can just go sit on the couch. Ladies and gentlemen, thank you for being our guest this evening.